We are looking at lesson 6.2's homework assignment, starting with number 1. So it says fill in the blank. In a constant increase or a constant decrease situation, all the points lie on the same what? So if you take a look at the picture right above it, this is a constant increase. It doesn't go up and down and all over the place. Constant increase or constant decrease, you can see that is going to form a line. What is the constant rate of change between any 2 points on a line called? So when you have a constant rate of change and you get a number to represent that constant rate, whether it's a very fast rate, very steep, or very flat rate, gradual, that is called your slope. Okay, number 3. The table at the right lists the height of a burning birthday candle in centimeters based on time in seconds. And you've got your ordered pairs for the time and the height. And the relationship is linear, meaning it forms a straight line, which means it's a constant rate of change. It's not going to burn really fast and then burn slower or vice versa. It's going to be a constant. And if you take a look, the height is going down. It was at 5.7, and this should make sense. The longer the candle burns, the shorter it's getting as less and less candle is there. So starting with 3A. Find 2 more ordered pairs. So if I was doing this, I would just go ahead and find the next 2. So my ordered pairs is going to be 6 something and 7 something. And so I'm just going to follow the pattern. It's going down by 0.3 every single time. So if I go down another 0.3, that is 3.9. And if I go down another 0.3, it's 3.6. You only had to do 2 more, but if you went another one, then that would be 3.3. Okay, so any 2 ordered pairs that would fall on this. Letter B, find the rate of change between any 2 points on the table. So we've already discovered it. It's going down 0.3. That is the constant rate of change. You could go ahead and show the work using y2 minus y1 over x2 minus x1. But in this case, since this is counting by ones, every single 1, it's going down 3. So that's a negative 0.3. And then letter C, explain what that means in the real world situation. So something about the candle burns down 0.3 centimeters every second. Okay, number 4. Table at the right gives coordinates of points on a line. If the pattern in the table is continued, what ordered pairs should be entered in the next row? So we're filling in the blanks. So following just the pattern, 14 is going to become 16. And over here, I'm going up by 6 every single time. So if I go up by 6 from 47, that's going to be 53. That's part A. And part B, what is the slope? So here, you can't just say it's 6 because it's not going up by ones. So y is going up by 6, put that on top. X is going up by 2. And so if I simplify that, my slope is 3. For every 1 that goes up with x, it goes up by 3 over here. Because if you imagine between 6 and 8 would be 7, between 23 and 29 would be 26. It's going up 3 for every 1x. So we need to make sure that this simplifies down, and it's 3. And you could go back and use your slope formula as well, y2 minus y1 over x2 minus x1 to get that. But it's not necessary on this one. We're about to do a bunch of them, so we'll practice them right here. So number 5, calculating the slope through a pair of given points. So again, y2 minus y1, x2 minus x1. It doesn't matter which one you call which. So when I'm given these, I just like to go straight across. You can do it however you want. Or I'll just double check it and see if I'm going to create a bunch of negatives, then I'll just go the other direction. So 4 minus 19 is going to give me a negative. 0 minus 3 is going to give me a negative. So instead of going that direction, I'm just going to go the other way. But since both of them would give you negatives, they would cancel and give you a positive. So if I go the other way and get positives, it still ends up being the same answer. So subtracting my y's, 19 minus 4. Subtracting my x's, 3 minus 0. Okay, so I get 15 on top. I get 3 on the bottom for a final slope of positive 5. Number 6, I'm going to jump right in here. Subtracting my y's, 8 minus 3. Subtracting my x's, I've got to go the same direction. So negative 6 minus 4. You could have done 3 minus 8. Then you would have had to do 4 minus negative 6. So 8 minus 3 is 5, and negative 6 minus 4 is negative 10. So I do need to simplify this. Only one of them is negative, so that means my whole fraction is negative. I'm just going to go put it out front, and 5 over 10 is 1/2. The negative can go in the top, in the bottom, or out front, but it's only one negative, not two negatives. Negative 1/2. Number 7. Okay, just calculating slope again. So 11 minus 1 is my y's. 5 minus 2 is my x's. So it's 10 over 3. Can't simplify that anymore. That's done. Part B, find the slope through these 2 points. Now for this one, because I see these negatives over here, I'd rather do 11 minus negative 18 because that's just going to go plus plus. So I'm going to go that direction here. 11 minus negative 18 will just go plus plus. And then 5 minus negative 4 will go plus plus. So 5 plus 4 is 9. 11 plus 18 is 29, and that doesn't simplify any more than that. So that's it. Now part C, do the points 2, 1, 5, 11, and negative 4, negative 18 lie on the same line. So that is all these points here. So if you notice, we found the slope between 2, 1, and 5, 11. Then we found the slope between that same 5, 11 and this other one, negative 4, negative 18. Now, they were different slopes. So just imagine two different slopes. We've got this steepness and then another steepness. And then maybe it's negative and then another steepness. So if you're taking all these points where there's different slopes between them, you can't say they're all on a line, okay, because the change happens in the slope. So if we got the same slope here, so between this point and this point, same slope. Now from that point to this point, same slope. That means they are all on a line. So if we test using 3 points, the slope between two of them, and they're not the same, then we know they're not on the same line. So letter C, we would say, no, not on a line. And I would just say the slopes are different. All right, number 8. So number 8, we're finding the slope from a graph. You can always go back to the basics, and you could look at these dots and calculate the points and just go ahead and use your y2 minus y1 formula. If you just like a one way to do everything, you can just go ahead and do that. But if I'm giving a graph, I'm just going to count the up and down. So the change in y is represented up and down, and the change in x is side to side. So for number 8, line L, first of all, we always read these from left to right like you're reading. So as I go from left to right, line L is going down. So I know that this is a negative. And I'm just going to go, you can do it actually between any points that you want. So here's the 2 points that are given on line L. So that's down 3 and over 2. The change from this point to this point, the change in the y value is 3 because we went from 3 to 0. And the change in the x value is 2 because we went from negative 3 to negative 1. So we went down 3, we went over 2. So that's negative 3 over 2. And number 9, I'm just going to put it right next to it. Line M is going up, that's positive. And from this point to this point, it goes up 2 and it goes over 1. So up 2 over 1, you can leave it just like that, or you can just write it as 2. Let's say you had gone from this point and you went all the way up to one of these. So you went up 1, 2, 3, 4, and over 2. Up 4 over 2, what's the slope? 2. So it doesn't matter, and you could even go to the next one. Up 1, 2, 3, 4, 5, 6, over 1, 2, 3. 6 over 3 is 2. So it doesn't matter which points you go between on one of these graphs. If it's a straight line, the slope is constant, and so it's always going to give you the same answer. All right, 10 and 11. We're only doing part B's on these, so part B is just finding the slope. So now I found the slope between two given points. I found the slope on a graph. Now I'm going to find the slope in an equation in y equals mx plus b form, where y is by itself. The coefficient right here is your slope. So in this case, we're sitting right in that. I'm just going to go ahead and write it down so you can see it. Y equals mx plus b form. The m is negative 4/3. So that's the slope. So that's your answer. Negative 4/3 is your slope. So we love this form. It just automatically gives us the slope, and it also gives you a y-intercept where it would hit the y-axis when it crosses it. But they're not always in that nice, pretty form. But if they are, we're happy because it just gives us our slope. So for number 11, 6x minus 5y equals 30. You can't just look at this and say, here's my x, so my slope is 6. Our slope is only given to us when we're in y equals mx plus b form. So we have to get it there. So here's my y. I need to get everything away from my y. So I'm going to minus 6x to get it on the other side. So I'm still going to have negative 5y. Over here, you could write 30 minus 6x. Because I'm trying to get it in this form, I like to put x in front. So since I'm minusing 6x, that's negative 6x. It's a positive 30. It's a plus 30. So if that doesn't make sense, write 30 minus 6x. And now I'm going to divide by negative 5. Everything gets divided by negative 5. So y equals, this goes away. Two negatives make a positive. Okay, so this is 6/5 x. And this is going to be negative 6. And again, now we're in that y equals mx plus b form, where slope is my m. So my slope right here, and the answer to the question is 6/5. All right, next up is number 12. So we're looking at the graph. We're going to do two things: find the slope, and then describe what the slope means for the real world situation that it represents. So number 12, I'm going to go ahead and do my y2 minus y1. I think that's the easiest way here to do it. You can pick any points on here that you want and go between them. So I'm going to go ahead and go between here. So my change in y's is 160 minus 80, and my change in x's is 2 minus 1. So I'm going to get 80 over 1, which is just 80. And since this one is counting up by ones, you actually could just see that the increase of the y for every 1x is 80. It goes up 80 and up 80. But running through the formula will give you that as well. Okay, so the slope is 80. That's part A. And part B gives some real world meaning to it. So the ounces of ground beef is what the x value is. So 1 ounce of ground beef, 2 ounces of ground beef, 3 ounces of ground beef. The 80, the 160, the 40, and that's really what we're measuring the change in. That's the y, and that's the calories. So the constant increase is 80, and that represents that every ounce of ground beef has 80 calories. So every time you increase the ounces, it goes up by 80 calories. So 13, same idea. First of all, I see this is going down, so I immediately recognize that this is a negative slope. I'm just going to go ahead and use my y2 minus y1, x2 minus x1 formula. You can pick any 2 points that you want, so I'm just going to work between these first two. If I subtract my y values, it's 48 minus 47. Got to go the same direction. So if I went from 48 to 47, I got to do 0 minus 5. So I'm going to get a 1 on top, and I'm going to get a negative 5 on the bottom. That should make sense. I already looked at the line. I knew I was going to get a negative answer. And so I'm just going to rewrite it because I don't like the way it looks with the negative on the bottom. But this is actually correct. You can leave it like this. I'm going to put the negative in front. Both of those are fine. And this is talking about how much water is in a bathtub over time, so for every second. And so what this means is that water is being removed from the bathtub at a rate of 1 gallon every 5 seconds. So again, this is the gallons, that's your Y, and this is seconds. So we are subtracting 1 gallon every 5 seconds is draining from the bathtub, something like that. Just remember when we have these fractions like this, and you could have put this over 1 up here, this is your Y and this is your X because that's what you subtracted. And so you can always look back. Y is your gallons, so it's 1 gallon. X is your seconds, so 5 seconds. So 1 gallon every 5 seconds, and it's negative, so that means that 1 gallon's coming out of it. All right, jumping to 15. Suppose you graph the data below in the chart. So we don't have to graph it, just imagining that it's graphed. Letter A, what's the unit of the rate of change? So I'm not looking for a number. Unit is just talking about what this represents. Degrees Fahrenheit and time. So we're talking about how many degrees it's changed over a certain amount of time. Now, specifically in this is going by hours. And so this is degrees of change per hour. So when we figure out what the rate of change is and we say, oh, it's increasing this many degrees per hour, that's the unit. When they say unit, that's what they're talking about. Not the numbers, but what they represent. And so to write this out in a real world situation, describe the real world meaning of the rate of change. So the rate of change describes the change in temperature over time. Okay, so we would put a number to it. We're not asked to in this specific situation, but the actual rate of change is going to tell you specifically how much the temperature is changing based on what time it is. Okay, so that's just putting a little more specifics to what's going on here. All right, after 15, we're at 16. So looking at a graph, so first of all, before you even worry about these numbers, it really doesn't matter the fact that these are fractions. You don't have to get messed up with that. If you look at our 3 lines that are here on the graph, one's positive going up, that's letter M. One's negative going down, that's letter L. And one is a 0 slope because it's not increasing or decreasing, and that's N. So when I come over here, this is real easy. Slope is 3/5, positive 3/5. So that has to be letter M. B has a negative slope. Forget that it's 3/5. It doesn't really matter. It's negative. It's going down. That's L. And then letter C, the slope is 0, meaning it's not going up, it's not going down. That's letter N. Okay, 17. You have these 2 points. We're missing one of the values. They're on a line, and the slope is -4. So we want to find the value here. So I'm going to go back to this formula. And I'm going to fill it in with what I've got. So I don't know what this value, y value is. So when I'm determining which direction to subtract, I'm going to look at my x's. So I want to do 5 minus 4. So that's the direction I'm going to go. So when I set up my y's, I have to go from left to right. I'm going to go 7 minus y. I don't know what it is. And my x's is 5 minus 4. I'm going to go ahead and simplify this. Can't do anything with 7 minus y, but 5 minus 4 is 1. And the information they told me is that my slope has to equal -4/1. So I haven't answered the question yet. I have to figure out what y is. But as I match things up, I've already got the 1 on the bottom, so there's no adjustment needed. So 7 minus something has to come out to negative 4. So if you want to write that as a separate equation, you could. 7 minus y equals negative 4. Some of you will just look at this and figure it out in your head. It's 7 minus 11. But if you couldn't figure that out, you could go ahead and solve the equation. Remember, when you do that, you're going to be left with a negative y here. So you're going to get negative 11 here, but then you do have to divide by negative 1. And so y equals positive 11. And you should always go back and plug it in. If I put 11 here and I did 7 minus 11, I would get negative 4. And the 5 minus 4 would be the 1. And so that's my nice slope of negative 4, which is what I wanted. All right, we're going to number 20. Some quick review questions. So we have a high-rise building that's being built at a constant rate, so it has a slope. Then they give you some information. The 18th floor was completed on the 24th day. The 81st floor was on the 108th day. Calculate the rate of change in floors per day. So we're going to take the number of floors and the change in floors over the days. So it's floors per day. So if we go ahead and look at the change in floors, 81 and 18, that's going to go on the top. And the days is going to go on the bottom. So 108 minus 24. And again, this is the floors, and this is the days. So we're going to calculate the change in the number of floors and the change in the number of days. And so when I do 81 minus 18, I get 63. And I do 108 minus 24, and I get 84. And so since this is not a perfect number, I'm going to go ahead and divide it. So 63 divided by 84 gets me 0.75. And again, what does the 0.75 represent? That's how many floors they're building per day. And in the book, they wrote that as 3/4. We should know 75 cents is 3/4 floors per day. 21. Okay, going way back, just solving one of these inequalities. A couple steps to go through. First thing I would do is distribute here. So that's 6p minus 6 plus 2p. I'm going to go ahead and combine like terms. Notice I'm staying on that side. Okay, I'm not doing anything over here yet. So finishing this off on this side, that's going to be 8p minus 6. Now I'm going to go ahead and bring down this. I've got a p on both sides. They happen to be the same. So right away I notice, okay, I'm going to go ahead and subtract this, and that's going to eliminate my variables altogether. And so at that point, I'm just going to be judging, is this a true statement that I'm left over with, or is it a false statement? So it's going to say negative 5 is less than negative 6. This is not flipping or anything like that, because I didn't divide by a negative number or anything like that. So negative 5 is not less than negative 6. This is not a true statement, and so there is no solution. If it was a true statement, the answer would be all real numbers. I think I can squeeze this all on one page here. So we're going to go 22. Now, they tell you to compute this in your head, and you might look at that and be like, how in the world am I going to compute 16 out of 64 as a percent in my head? 16 is what percent of 64? What they assume that you know is that 16 goes into 64 perfectly 4 times. So that'd be like me asking you, 1 is what percent of 4? So 1 out of 4, that's the same as 16 out of 64. It goes in 4 times. If you do 64 divided by 16, it goes in 4 times. So think about percent. When something goes into something 4 times, that is 25%. And if I doubled 25%, I should be at 50%. So if I double 16, I'm at 32. 32 and 64, that's half. That's 50%. And then part B, we're still thinking along the same lines now. 75%, again, is cutting something into 4 pieces and taking 3 of them. So if I take 80 and I cut it into 4 pieces, it's 20, 20, 20, and 20 for a total of 80. So 75% of that is 3 out of those 4, so 20, 20, and 20. And so the answer is 60. So that's how you're supposed to do it in your head, is to just know that 75% and 25%, 50%, is cutting it into 4 pieces and then either taking 1 of them for 25%, 3 of them for 75%, so on and so forth. So that's how they expect you to do it in your head. And then last one, 23. We have this initial equation of 5a equals 1/2 b, and then it changes to 20a equals, and we're trying to fill this in. So you got to figure out what happened. Just looking at this, what did we do to the 5a to create a 20a? We times it by 4. So we know the property holds true, where we can multiply both sides of the equation by the same number, and they're still going to come out equivalent. And so I'm going to go ahead and multiply 4 times 1/2 b. 4 times 1/2 is just 2, and the b stays. And so this is what fills in the blank. That's the answer of 2b.